Good afternoon, everyone. Thank you for continuing with TD Cowen Sustainability Week. I'm David Deckelbaum, lead on Next Generation Materials, and I'm privileged to be joined this afternoon by Ryan Melsert, the CEO of American Battery Metal Technologies. Ryan, thank you for joining us this afternoon. We're looking forward to hearing more about your company and some of the exciting endeavors that you have, and certainly a differentiated profile within sort of the lithium battery supply chain. I will note to those of you on the line, if you'd like to submit some questions that you want me to ask Ryan, I'm happy to do so under the dashboard, and I'll review them and send them along his way. But Ryan, maybe for those of us on the line or others that might not be familiar with the story, can you give a little bit of a background of how you got involved in sort of lithium exploration and ultimately battery recycling? A brief little overview of the story here and where some of your initiatives are lined up currently.
Yes, of course. Thank you, David. It's great to be here. So I've been working in the lithium material space for close to 20 years now, initially more on the R&D side, developing new types of selective absorbents for manufacturing lithium from different types of unconventional resources. I went to work for Tesla back at the start of 2015 and was part of the initial design team to build and commission the first battery gigafactory in the world. So it was obviously a very intense time, really designing and implementing each individual stage of the battery manufacturing operations. So we gained a very fundamental insight into the things that can go correctly and that can go badly in the processing and manufacturing of battery materials. I did that for my first 2 years at Tesla, and then my third and fourth year, I moved over to the R&D division and formed my own team that I called the Battery Material Processing Group. And we were working upstream of cell manufacturing, looking at how we could take raw ores and brines that contained lithium and nickel and cobalt, and really how we could develop new first-of-kind processes for how to recover the material, how to purify it, and then new methods of manufacturing, active cathode material, and other cell components. So scaling up that facility from an empty piece of dirt to one of the biggest factories in the world was very empowering. But we saw that there was a new limiting factor in the supply chain. Right now there are close to 20 electric vehicle factories under construction just in the US, close to 20 very large battery cell gigafactories in the US. But there is not the corresponding upstream manufacturing materials happening in this country. So still less than 1% of all lithium and nickel and cobalt manufactured in the world is manufactured in the US. So we have all of these multi-billion-dollar factories under construction right now, and they don't have access to domestic material to feed them. And that makes them very vulnerable from a security supply standpoint. It makes it more expensive for them to receive their material from a cost of supply. And they generally have a higher environmental impact, where the material is harvested in less stringent environments and then transported throughout the world. So we saw that shortcoming as an opportunity. We formed ABTC a few years ago, and we've developed really two solutions to address those challenges. So end-of-life battery recycling is very important. Again, from the manufacturing days in the Gigafactory, we saw many operations that went well and many that resulted in essentially failed components. A lot of recycling systems today take whole batteries and drop them in a furnace or just drop them in a shredder, make these complex outputs, and then need complicated systems to isolate the materials. So what we really do differently is we have taken many of the same techniques that we designed and commissioned as part of the Gigafactory team. And essentially, we're able to run them in reverse order and strategically demanufacture batteries, separate out many of the byproducts early, and then have a very targeted chemical extraction train that's much lower cost to operate and has higher recovery efficiencies. So closing the loop is very important, so that once material is in the US, it then stays in that loop near indefinitely. And if we were at steady state operations, if there was a fixed amount of batteries in the field, then that would be enough. But that isn't the case. Yep. The battery industry in the US is growing dramatically. So in addition to closing the loop, we also have to fill that loop with material the first time. So our second business unit is really the manufacturing of battery materials in the US. And again, there are very conventional ways of processing battery materials from conventional resources like ores and brines. We intentionally have gone after an unconventional resource. So a sedimentary claystone deposit in central Nevada. We've secured over 10,000 acres of land, and we've developed our own first-of-kind process for how to recover and purify and convert a lithium hydroxide material that meets all the battery grade specifications. So we've won a few corporate awards and a few government grants over the past few years that are really helping us to scale up these commercial operations.
And if I take all of that as a very helpful overview, I mean, if you look at the differentiated expertise at ABTC as primarily being chemical engineers and the chemical process that you would be applying to one, just lithium ion demanufacturing versus maybe a mechanical separation. But then I guess it's also using a chemical extraction process for unconventional resource. Is that like a fair characterization of where you would fit as a differentiator?
Yes, I would say technology development and commercialization. So chemical processing is a big part of that, but we also go even much more upstream. Quite a few material scientists at our R&D level going through our engineering, our procurement. And then again, we're about 60 individuals, and about half of us, are my former colleagues from the Tesla Gigafactory. Yep. So the understanding of how to design and construct, very large scale construction projects is a very important skill set as well. So these lithium hydroxide refineries we're designing and constructing down in central Nevada, these are multi-billion-dollar projects. So having a team that has built multi-billion-dollar factories from an in-house engineering, procurement, construction before is very impactful skill set to have.
Yep. Maybe if I could expand on that a little bit, several of your colleagues from Tesla Heritage have come over with you and working on this project. Tesla currently, I think, has announced ambitions to build out a hydroxide conversion facility. When you think about being sort of a third-party independent lithium manufacturer, recycler, how do you think about that in the context of other OEMs or those that have gigafactories, having their own recycling operations, and the logic of fitting in as sort of this third party? Like what segment of the market can you kind of arbitrage there, or will it end up making more sense where you have incumbent OEMs that have a closed loop recycling solution?
As far as the lithium manufacturing, I would just say designing and building a refinery is very different than developing a mineral resource. So we intentionally do both of those in-house. So owning the own resource, developing it ourselves, and having the refinery directly on top of the resource. So that's very rare globally today. Many refineries are on different continents than mineral resources. So it dramatically reduces our material movement, having that refinery right on top of our property. So the hydroxide refinery you mentioned down in Texas is not at a resource site. So that feedstock has to be shipped from somewhere else in the world. So that does add complexity and that adds risk. As far as the recycling side, I mean, we speak and work with, essentially all of the automakers in the world. And every one of them really wants to have a recycling system in their closed loop, many times co-located with their factories, but very few want to design and develop and commercialize that themselves. They want to focus on their core competency, which is really more the powertrain design, the vehicle, the manufacturing. So it actually ends up being very complementary and synergistic to work with the large OEMs.
So that's something that you could implement as on-site in some sort of licensing or collaborative model where you're sharing in the economic benefits or on a contract basis?
Yes, many different types of business structures, but the important part is that when they're co-located facilities, it makes the logistics much simpler and much lower cost.
Yep.
And it's both sides of the closed loop. So it's receiving end-of-life material from the OEM and then selling the products back into their own supply chain.
Can we talk a bit about timelines on, maybe two different sides of the business? One, just beginning with how far along you are with the recycling plant, what the timelines look like around commissioning and securing materials. And then we can get into Tonopah Flats and some of the sedimentary rock.
Yeah, so for our first commercial scale recycling plant, the construction implementation of the facility is complete, and we're going through installation of the processing equipment right now. So we'll be commissioning that plant over the summer, and then expect first product out the door at the end of the summer.
Is there an expectation in terms of percentage of nameplate capacity that you would be operating at, or is the facility being sort of built out modularly to handle more capacity over time?
No, the full throughput of the processing equipment is being installed now, and will be essentially increasing the capacity factor as we go through the rest of the year.
Okay.
But it's all the equipment installed right up front.
I suppose we should see potentially first revenues out of recycling sometime in the third or fourth quarters then.
Yes, that's what we're planning for right now.
And then maybe we can talk about Tonopah Flats and where you are right now and sort of the timeline before thinking about production. If there's more exploration initiatives that you're looking at right now to expand the resource first, or how do you think about the development process there?
Yeah, so there's both the development of the mineral resource and then construction of the refinery. For the resource itself, we did 2 large sampling programs over the past year and a half. We published our maiden resource report back in March, showing that we have just over 15 million tons of lithium on a carbonate basis that's economically accessible. So that makes it, one of the largest resources in the country already. And we'd only explored about 2/3 of our property at that point. And even more importantly, we hadn't hit the bottom of the resource as a function of depth yet. So we'll be doing additional sampling really to expand the resource at the surface, but mostly at depth. That will allow us to take, essentially our inferred resource and move it into measured and indicated and eventually a proven reserve.
Yep.
And then in parallel with that, we are working on our refinery design. So we mentioned we won a Department of Energy grant about a year and a half ago, working with DuPont to build a field demonstration system. We're about halfway through that project right now, and we'll be deploying that demonstration system later this year. And then additionally, we just won a much larger grant back in October for a $115 million project to now build the commercial scale lithium hydroxide refinery. So over the past few months, one of the first steps was to do a formal bid process to determine who we wanted to be our lead construction firm for that. So again, many of these firms we worked with, during our Gigafactory construction days. We did a formal RFP process, reviewed about 12 different proposals from some of the leading construction companies in the world. And about a month ago, we just hired Black & Veatch to be our lead EPC for this project. Yeah. So we're just kicking them off now to essentially go through the construction design and the actual construction efforts for the first phase of this facility. So the initial production will be 30,000 tons per year of lithium hydroxide. And then because of the scale of the resource and the demand, especially after the passage of the Inflation Reduction Act, we're evaluating significantly increasing that capacity going forward as well.
Touched on the IRA, maybe we can jump into that and just some of the benefits that you've seen, or maybe how the business model has been influenced or informed or altered post-IRA passage. And maybe talk about that in a bit of, obviously anything that you manufacture in the United States is going to qualify as IRA compliant materials. How does that set up for thinking about financing or strategic partners as you build out these projects?
Right. And even before the IRA, there was significantly more demand for U.S. critical materials than there was supply. So selling the material wasn't the issue. But having something like the 30D program from the IRA is still impactful because it essentially places a premium on U.S. sourced material. But when you also look at more the ITC and the PTC sections, what they've really done is increase the manufacturing capacity in the US for the cell and vehicle side. So a big reason why we have, close to 20 factories under construction is because of the IRA benefits. So that essentially is built-in demand for the types of products that we make. So we'll directly benefit from the investment tax credit in the near term, the production tax credit on both sides of the business as we're running. And then the 30D subsidy program really just places a premium on our product. But I would say the biggest impact is really, again, just the quantity of facilities being built by our customers now, which really has that guaranteed demand for the foreseeable future.
And should we suppose that sort of potential offtake partners maybe announced in the next year or so become sort of like your primary or an important source of funding, especially around Tonopah Flats?
Definitely, there's very large interest. Many automakers are interested in buying, the entire production. So it really is about who we think is the best strategic fit as we go forward, because this will be much more than a contractual relationship. This will be a partnership going forward. And especially when we combine it with the rest of our business, also receiving end-of-life material to be recycled, selling recycled products back to the market in combination with our primary metals. So there are very few companies out there that can really offer both sides of that business. So the near-term recycling and the longer-term, much higher volumes of this lithium hydroxide material. And the fact that we make a hydroxide is also relatively rare. There are very few projects moving forward, lithium projects, and a couple of the large ones, make a carbonate product, which is difficult to use in the manufacturing of high energy density active cathode material.
Maybe just to step back a little bit, the demo plant that's being built, what's that going to be capable of doing? Is it taking just a lithium sulfite and getting to lithium hydroxide? Is it? I guess how fulsome is the demo plant in its capabilities?
No, it's much more than that. So it takes in raw sedimentary claystone from our resource itself. So all different types of material processing and beneficiation, going through each of our individual steps, and it actually makes a lithium hydroxide out the backside of it. So it has every unit operation that is needed. And that's why it's really so impactful, is it really lets us validate the integrated system and to optimize the conditions as we move into our commercial scale facility.
Can you maybe talk a little bit about just, operating with clay? We haven't seen lithium being extracted from clay at commercial scale yet, which can just be a coincidence of timeline of where the lithium industry is. But, what do you think is sort of misunderstood about managing clay? And is it really just a matter of the chemical technology that was being applied, or extractive technology just wasn't there historically, or there wasn't particularly an initiative to get it there?
I think part is that there just wasn't a lot of effort put into developing US-based resources. This industry really grew outside of the US. And the second part is, I think people saw a clay resource and they tried to apply a process flow sheet that was designed for a different feed material. So if they tried to apply a conventional spodumene-based process flow, you don't end up with an economic and competitive process. You really have to start from the beginning and make this a purpose-built system. So that's what we did about 2 years ago. And that's why it really does change the economics to have a process designed specifically for this type of feedstock.
Was the design at all is it an analog to any other claystone processing techniques used for other materials in other parts of the world?
It intentionally isn't. And I mentioned, we were able to win 2 government grants over the past 2 years on this side of the business. And in each of those proposals, we really highlighted what our process does differently, not just than conventional resources, but how our process is different from other proposed clay processing designs. Many designs that are proposed today have extremely high acid loadings, so high some plants are actually building a sulfur combustion plant right on site, combusting sulfur, oxidizing it, and actually hydrolyzing to sulfuric acid. right at the lithium refinery. That's very expensive on a capital basis and has a significant environmental impact. So we intentionally don't have anywhere near that kind of acid loading. So we don't need that type of sulfur combustion plant on our site.
Can we talk a little bit about just contracting or securing feedstock for the recycling operation? Where does some of the initial tonnage, I guess, come from? As you sort of commission the plant and bring that online, and how do you think about setting up to procure or receive feedstock in the future?
Yeah, there's really a couple buckets of it right now. So there are, disparate amounts that are really going through brokers and aggregators, people doing kind of more regional collection and pickup. Then there's more the damaged material from the end of life that really is at service centers and at secondhand vehicle companies. And then the third one is really, the defective material from the manufacturing process. So we work across the board right now to source the material. As we go forward, the vast majority is going to come from really the service centers and dealers taking full packs back end of life. So I think whoever is going to win the feedstock game and get the most access is really who can develop the best relationships and the best partnerships with the other portions of the closed loop supply chain. So we, as a battery material provider, we sell to chemical refiners, who sell to cell manufacturers, who sell to OEMs, and then it comes back to us in a closed loop. So that's why it's so important that we have these relationships. A few years ago, we won a global award from BASF, one of the premier chemical refiners in the US. We have relationships with many of the cell manufacturers. And then lastly, we won, an award from the US automakers, from Ford, General Motors, and Stellantis. So developing those relationships and how we really close that loop domestically is how you get access to the best feedstock and how you get the best offtake agreements for your products.
And I guess just to further on just the recycling technology, is the process agnostic of lithium-ion battery input? Is it agnostic on cathode type? Can it take lithium-ion battery in any application? Does it have to be specific to EV and specific under a cathode chemistry?
No, we intentionally designed the plant so that it can be fed with anything in a lithium-ion family, so the same processing train. But we do intentionally stage material into tranches to feed light chemistries at a time, which allows us to fine-tune the operating conditions based on what is being fed at that time. So we get a bit better recovery efficiency and lower operating costs by fine-tuning for that specific chemistry.
Yes, maybe in the last few minutes we have here, you all have come a long way in the last, several years, even just getting to the point now where I feel like first revenues are effectively imminent right now. You've made some headway on the resource side. What are some of the largest milestones you see sort of in the next 6 to 12 months that you're most, anticipating and you feel like most of the investment world needs to know a bit more about?
The commissioning of our, first recycling plant is obviously very important. We're in the middle of that right now. And over the next few months, as we transition to steady state operations and revenue, that will be a very big catalyst. We work with many of the large strategics on the automotive side, the cell side, the cathode refining side. As we finalize some of those relationships, like you mentioned, this industry will be much more than contractual. This is about partnerships and about how these bidirectional relationships and bidirectional material flows work. So as we formalize some of those partnerships, it will really solidify that business case about how we're moving forward. On our primary lithium on the Tonopah side, additional sampling on exploration of our property. I mentioned we've done 3 different depths of drilling. We started off around 500 feet, then around 700, and then down to 850. Still not finding the bottom of the resource means that there is huge possibility for continued expansion of the resource still. So in the near term, we'll be going to much greater depths, and we're looking forward to see where we really bottom out that resource itself, which can make a very big impact on our next technical report.
I guess what remains at Tonopah in terms of permits required to get to full scale development?
So last year we went through the permitting process for our field demonstration plants. So we went through each of the steps. We were able to receive all the permits needed to operate there. And again, being a Department of Energy funded project, had a few additional steps. So right now we're essentially going through the same process again, just for a much larger scale project. So the Bureau of Land Management in the area has been very helpful. It's very straightforward to work with them. And I think most importantly is the town of Tonopah really has a very long history of mining operations, mostly the silver and gold area. So it's very important. We feel very welcomed in the community. Many of our team members actually have lived there most of their lives. So we already feel like we are part of the community, and they're excited for us to move forward as well. So our community engagement is very positive, and they're excited for us to move forward with the next steps.
Do you anticipate how long sort of the next phase of permitting takes to get to full plant?
There are several we're already in the midst of right now. And again, working with Black & Veatch for the large scale construction of the refinery as well. So right now we're looking for the development and construction, through 24 and early 2025, and then commissioning of the refinery end of 25 and early 26. So looking for large scale production in 2026. And when you look at a lot of these electric vehicle and battery cell plants coming online, the vast majority are scheduled to be ramping in 2025 and 26. So it's very well aligned with the increased demand domestically.
Ryan, I appreciate you coming by today and having a chat with us. Thanks for sharing all the information about American Battery. I appreciate always engaging with you and looking forward to seeing you at future events.
Definitely. Were there any questions from the audience that you wanted to go through?
I think I've sort of filtered through a decent amount of them. And I think many of them, as you can imagine, are largely around timing of seeing first products coming out of the recycling. I think that's obviously an approaching catalyst that's pretty heavily anticipated right now.
Definitely understandable. It's something that we're excited about as well.
Well, best of luck to you, and I'm looking forward to that update in the next couple months here.
Thank you. Great speaking with you.
Sure, Ryan.